Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your mineralogy teacher, Jen, and it's time for one last Monday's mineral. We will be talking about aluminum today. So aluminum, or aluminium, if you are British or other countries. Some countries say aluminium, others say aluminum. They both came around the same time, and then there was just like a divide, and that's just what happened. But it's been around for a long time. We've known about it since at least the 5th century BCE. So, well-known metal. It has a much lower density than most other metals. It's BFFs with oxygen, which creates a protective layer of oxide on its surface rather than just destroying it and annihilating it like many other poor metals. It strongly resembles silver with its silvery white color, as you can see in this photograph. Sometimes it's gray depending on the roughness of the surface. You can see a little bit of that in here too, where you got like this gray edge in here. And it has high reflectivity. If I can speak, that'd be great. It's almost as good as silver. In fact, it's better in ultraviolet light, and does pretty good with infrared light, infrared as well. Yes, the struggle is real today, my friends. It has a hardness of about 2.5, which makes it pretty soft, and it's also very malleable and ductile. Most of us know this. We use aluminum foil for a lot of things, and it's very easy to mold and shape the way we want it to. As you may have already guessed, like with other metals we have discussed up to this point, it has a face-centered cubic crystal structure. They're so predictable. Aluminum is the 12th most abundant element in the universe. The only stable isotope, aluminum-27, is formed by fusion of carbon in stars that will become Type II supernovas. These are really big stars, my friends. It is the third most abundant element in Earth's crust after oxygen and silicon. Surprise, surprise, that makes up a lot of rocks. And part of the reason it's the third most abundant is because it forms oxide minerals so easily, because it's so tight with oxygen. So here are some of the elements. Here are some of the minerals that contain aluminum. So all of these are feldspars. So potassium feldspars, sodium feldspars, calcium feldspars. So plagioclase and things like that. All of these are aluminum, have aluminum in them. And if you're relatively new to my channel, I do have a feldspar video on YouTube that like goes into a little bit more depth about what feldspars are, because there are so many of them and they're super cool. So I will put a link in the description of this video so you can go watch that one too. So let's take a look at some of the minerals that aluminum is a part of. These are all feldspars, so you can see that I have the formulas written out for you, so you can see what they are. Some of them are potassium feldspars, and then there are sodium and calcium plagioclase feldspars. If you want to learn more about feldspars and you're new to my channel, I actually do have a full-length video on YouTube about feldspars because they're super cool, and that's the link there, so you can check that out. I'll also make sure there's a link in the description that hopefully will be clickable. It's also a part of beryl, cryolite, which looks a little bit like quartz from this photograph, some types of garnets. You can see from this bracketing here that sometimes you have chromium, sometimes you have aluminum, sometimes you have iron. Not always going to be aluminum. It's part of spinel, part of turquoise, and my personal favorite, corundum, which is better known as either rubies, like what I have here in my hand, or sapphires. So yes, I have this because it's my birthstone, and I love rubies. Now this here is bauxite, and it is the most common aluminum ore, so this is where we get a lot of the aluminum that we use in our daily lives, from this little rock here. Not this particular rock, but, you know, rocks like it. Aluminum is very important because of its lightweight nature. Many vehicles used for transportation are made out of aluminum, such as cars, bicycles, airplanes, and even spacecraft, because it's light. We can get it up in the air, and we don't have to worry about a lot of other things that we'd have to worry about with heavier metals, denser metals. Plus, unlike some metals, it's also non-toxic, so we use it to package food or line bags of food to keep food fresh, because it's not going to poison us. It's an excellent conductor of heat and electricity, so we use it a lot in cooking. Baked potatoes are probably the most famous example, but if you like grill corn, or out in the field we'll line our cast iron pan, or cast iron Dutch ovens with aluminum foil so that our baked goods do not stick to the cast iron pot. And it cooked them, well, in theory, cooked them faster if we could just get the fires hot enough. Let me tell you, sometimes fires just don't cooperate in the field. Well, hopefully you were able to learn something fun and new and interesting about aluminum today. Tune in tomorrow for one last metallic trivia, and I will fossilize later.